this is Snigdha. She want to find the height of the tree, but not sure how to find the height of the tree. So shall we help her to find the height of the tree now? Yeah, let's come on. Now we place a mirror on the ground so that the image of the top of the tree will fall in the mirror, and so that Snigdha can see the image of the tree in the mirror. So now if we observe the figure, here we can notice two triangles are forming with the position of the tree and Snigdha. And those two triangles are the right angle triangles because tree and Snigdha both are perpendicular to the ground. So now, can I say these two triangles are the congruent triangles? No, here triangle ABC and triangle CDA both are not congruent triangles since they may be of the same shape but not of the same size. So geometrically speaking, if two polygons are of the same shape but necessarily not of the same size, then they are similar. So what is the purpose of discussing similar polygons now? So definitely there is a purpose because we use the concept of similarity of the polygons to find the height of the taller objects like trees, buildings and mountains, or if you want to find the distance between the further objects, we use the concept of similarity by using its indirect measurements. Okay, so now let us discuss about the similarity of different polygons and the similarity of triangles in this chapter now.
We can see here some regular polygons. The examples of regular polygons are square and equilateral triangle. So we can observe in a square, we have all the angles as 90 degrees. And if we take the sides of the square as A units, and the other square has B units. Now, if we consider the corresponding angles, that means angle A and angle B. And clearly it is angle A and angle B both are 90 degrees, so they are equal. And in the same way, angle B and angle Q, these two are the corresponding angles, and these are also equal. So we can conclude that angle D and angle S are also corresponding angles, and they are also equals to 90 degrees. And angle C, angle R are also corresponding angles which are equals to 90 degrees. So finally, we just take the ratios of the corresponding sides. That is AB by PQ, which is equals to A by B. And in the same way, if we check for other sides ratios, that is BC by QR, which is again equals to A by B. And if you go for the other rest of the sides, DC by SR, which is also equals to A by B. And clearly we can say that AD by PS is also equals to A by B. So that means we can say that the corresponding angles and the corresponding sides ratios is equal. So it is the same for equilateral triangle as well. So when we are talking about the regular polygons, they are always similar. So what we can say about the circles now? Can they be similar or congruent? So if I talk about the circles of same radii, so they are always congruent. So circles of same radii are always congruent, but circles of different radii now, what we can say about the circles of different radii? They are definitely not congruent. Then we can say circles of different radii can be similar. Why? Because they remains the shape as same, but their size is varying. So finally, what we can conclude that all the congruent figures are similar, but not all similar figures are congruent. Now let us discuss about irregular polygons. We have a square, rhombus, and rectangle here. We know that a square and rhombus both have the equal sides. But when coming to the angles, square has 90 degrees, whereas rhombus has not 90 degrees. Now, when we are speaking about a rhombus and a square, are they similar now? So definitely they are not. Why? Because if we talk about their corresponding ratios like AB by PQ, which is equals to A by A, and which is again equals to the rest of the ratios of the other sides, that is BC by QR. So it is true for all the sides, which is again A by A. And if you take DC by SR, it is also equals to A by A, and it is true for the other two sides also. So now when we are speaking about the corresponding angles, like angle A is not equals to angle P, because angle A is 90 degrees, whereas angle P is not 90 degrees. So in this case, a square and rhombus, they are not the similar figures when we are discussing about the corresponding angles. Now let us discuss whether a square and a rectangle are similar or not. So when we are talking about a square and rectangle, we know that in a square and rectangle, both have the 90 degrees angles for all the corresponding vertices. Now, what do you say about the corresponding sides? So now let us consider AB by LM. So here the length, both the lengths are having A units, that is A by A. And now if you talk about the breadth, BC by MN, so which is equals to A by B. So clearly we have AB by LM is not equals to BC by MN. So we say here, we can conclude here a square and a rectangle is also not a similar figures. Now when we talk about a rectangle and a rectangle, so clearly we have that both are having the 90 degrees angles. So when we are discussing about the corresponding angles, all the angles are equal. When we discuss about the sides now, so now let us take the corresponding sides for this. So what are the corresponding sides we have here are LM by L dash M dash. This gives me A by C. And this is also same for ON by O dash N dash, because we know in a rectangle the opposite sides are equal. So now when we are talking about the lengths, their corresponding sides are having the equal ratios. But when we are talking about the breadth, like MN by M dash N dash, so we have the ratio as B by D, so which is not equals to the other two corresponding sides. So in this case, we say that the two rectangles are not similar. So is it true every time? Then it is not true every time. So two rectangles can be similar when their scalar factor is same. So what is the scalar factor then? So the scalar factor is that simple. The ratio of two corresponding sides is called as a scalar factor. A scalar factor is constant for all the corresponding sides. So when we are getting the scalar factor of the corresponding sides, if they are proportionate with the length and the breadth, then two rectangles are said to be similar figures. Let us go back to Snigdha's example now. We have two triangles formed in the example. So these two triangles are similar triangles now. So triangle ABC is similar to triangle CDE. So in these two triangles, we can say that the corresponding angles A is equals to the corresponding angle E, and the corresponding angle B is equals to the corresponding angle D, and corresponding angles ACB is equals to the corresponding angle ECD. So all these angles are equal. So when we are discussing about the corresponding ratios again, it is AB by ED is equals to AC by EC is equals to BC by CD, and this is all equals to some constant K. So this constant K is called as a scalar factor. So we have discussed it earlier. A scalar factor is nothing but the ratio of the corresponding sides is a scalar factor, and which is a constant number. So now we can say that if the scalar factor is greater than 0, if your scalar factor value is greater than 0, so that means we can enlarge an object. We'll get an enlarged object of the original figure. If scalar factor value is just like equals to 0, so that means these two figures are the same figures. That means their measurements are same. So now if scalar factor value is less than 0, so that means when you are taking the original picture and you will get the diminished figure. That means you will get a smaller figure than the original figure. So whether you will get a larger one or the same one or the smaller one, it is depending only on the scalar factor. So now we have observed here the corresponding angles are equal. So when all the corresponding angles are equal in a triangle, in two triangles, we call them as an equiangular triangle. So here in our example, triangle ABC and triangle CDE. Both are the equiangular triangles. So when we say two triangles are equiangular triangle, so definitely their corresponding ratios are equal. So now how can we prove this one? How can we say if two equiangular triangles, their corresponding angles are equal? How can we prove this one? We have a theorem called basic proportionality theorem. The basic proportionality theorem states that if a line L is drawn parallel to one side of the triangle, then this line intersects the other two sides in two distinct points, say D and E. Then the other two sides are divided in equal ratios. So that is, we are required to prove that AD by DB is equals to AE by EC. And this is the condition what we are going to prove when if DE is parallel to BC. So this is what the basic proportionality theorem says for us in a triangle ABC. So now if we observe the line L is dividing the total triangle in two parts. That is, one is a triangle and the other one is a quadrilateral BDEC. So now let us take the triangle part. So in the triangle part, I can draw a perpendicular line from vertex E to the base AE. So that DN, I'm calling this as DN. So this DN will be the height of this triangle. So we can find the area of the triangle ADA. So let us find out now area of triangle ADE first. With respect to the height DN. So this is equals to half of base AE into height DN. So call this equation as 1. So now we can draw another height as well for this triangle. So from vertex E, I will draw another height with respect to the base AD. So why I'm choosing with respect to AD base and EN base? Because something we have to prove with the side AD and AE. So that is the reason I'm choosing AD base and AE. So now we can find out the area of triangle ADE once again, but this time with respect to the base AD I am finding. So it is half into AD as a base and we give the height as EM. So EM is the height. So let us mention this is the second equation. So in the quadrilateral, we can observe that we can divide this quadrilateral in two triangles. That is, one triangle is BDE, an obtuse angle triangle, and the other triangle will be CDE triangle. So this is an obtuse angle triangle. So now we can say that the area of these two triangles, BDE triangle and CDE triangle, are equal. So let us mention that area of these two triangles are equal. So here, area of BDE triangle is equals to area of CDE triangle. So why they are equal? Since in a quadrilateral, the triangles drawn between two parallel lines with common base. What is a common base? We can see here. DE is the common base for the two triangles. So then their areas are equal. So this statement we are using to prove this basic proportionality theorem. So now here the two areas are equal. So now for these two triangles, these are the obtuse angle triangle we have. So for an obtuse angle triangle, for finding the height, we know very well the height of an obtuse triangle is always falling out of the triangle. So with respect to base BD, I will talk now because I want the other part of the proof is DB. So here I have the base DB. So for this DB, the opposite vertex is E. So from vertex E, if I draw a line perpendicular, so to the extended line of BB. So this is falling out of the triangle and this line we can name it as DEM. So again, for the BDE triangle, the height is becoming EM.
So let us mention the area of this part. Here we write area of triangle BDE with respect to the base DB is equals to half of DB into height is EM. Call this equation as 3. And in the same way, we can find out the area of the other triangle as well. So area of triangle CDE. So here the base with respect to EC and height is D. From vertex D, we can find out the height with respect to the EC base. D as the vertex. From vertex D, if I take a line perpendicular to the extended line of EC, it will be definitely DN now. So DN become the height. So it is equation 4. So you can observe that in first equation and fourth equation, we have the common height DN. So I will divide area of triangle ADE by area of triangle CDE. Then after I can divide area of triangle ADE by area of triangle BDE because these two are having the common heights. So why I'm choosing only these particular equations is because if you divide these particular equations, you will definitely get AD by DB. So we choose equation 1 and 4, then equation 2 and 3. We divide the areas of triangle ADE and CDE. So ADE triangle area is given as half into AE into DN by half into EC into DN. So here we can cancel out the common heights and half. So finally we got it area of triangle ADE by area of triangle CDE is equals to AE by EC. And in the same way, we can find out the other ratio as well. So take the ratio of area of triangle ADE by area of triangle BDE, which is equals to half of AB